Welcome to this masterclass on strategic safety governance. Today, we're undertaking a rigorous, elite-level training session focused on proactive environmental health and safety governance, specifically tailored for tertiary institutions. This isn't about running through basic compliance checklists. We are going to talk about engineering safety as a core institutional system. Whether you're a vice chancellor, a facilities director, or a safety professional, your objective today is to master the architecture of risk control and sustainable campus operations. Look, we need to begin with a stark reality. Failing to meet your institutional duty of care is not just an administrative oversight, it's a critical liability. Breaching health and safety laws is a criminal offense, one that can literally lead to heavy fines or even imprisonment for responsible officials. If a serious incident occurs and an investigation finds your university was negligent, the financial and reputational damages are completely catastrophic. The stakes are incredibly high, and as university executives, you possess a non-negotiable fiduciary duty to mitigate these risks proactively. Here is the exact progression of our curriculum today. First, we'll map out the campus risk ecosystem. Then, we dive into institutional safety governance, operational risk and control, emergency preparedness and response, and finally, we'll establish the systems for compliance and continuous improvement. Part 1. The campus risk ecosystem. Think about a standard corporate workplace for a second. It's predictable, right? Standard traffic, single-use spaces. But a tertiary campus is a completely different beast. It's a dense, highly dynamic environment. You've got academic layers, residential halls, high-voltage infrastructure, and industrial-grade laboratories, all existing in these overlapping risk zones. A chemical spill in a lab doesn't just affect the academic layer. It impacts building infrastructure, environmental safety, and the dense population of students navigating the halls. Because risk is networked and dynamic in this kind of ecosystem, safety cannot be treated as some isolated administrative function. It absolutely has to be engineered systemically. Now, to effectively operate within this complex ecosystem, we have to establish a non-negotiable baseline. You must strictly differentiate between a hazard and a risk. Listen, a hazard is simply a source of potential harm, like exposed electrical wiring or a volatile chemical. Risk, however, is the evaluated likelihood and severity of that harm actually happening. The probability of electrocution in a crowded classroom versus a locked maintenance closet completely changes your risk profile. Understanding this distinction is literally the first step you have to take to prioritize your controls and allocate your resources intelligently. Moving to Part 2, Institutional Safety Governance. Let's look at a real-world elite benchmark. The University of Western Australia's Leadership and Governance Framework shows exactly how structural authority needs to cascade. It flows seamlessly from the Chancellor and Senate, who hold ultimate strategic accountability, straight down to the executive management team, and then right to the operational directors who develop the plans. The key takeaway here: systemic safety failures are rarely just missing policies. They are almost always failures of governance. If your authority and accountability aren't legally bound together from the absolute top down, your entire system will eventually collapse under pressure. To prevent that kind of collapse, world-class institutions use a strict three-tier governance system. Tier 1 is strategic governance, where the board and vice chancellor set policies and allocate budgets. Tier 2 is tactical governance, where the EHS directorate and safety committees translate those policies into workable systems. Tier 3 is operational governance, where technicians, staff, and contractors actually execute those procedures on the ground. Now here is the absolute most crucial rule: you must never mix these layers. When executives try to micromanage ground-level tactics, or when technicians are left to invent strategic policy, you create systemic confusion. Clear boundaries equal flawless execution. Part 3, Operational Risk and Control. So how does all this top-tier governance actually translate into physical risk mitigation on the ground? It's all about the hierarchy of controls. This is a strict, non-negotiable sequence you apply to every single hazard on campus. First, elimination. Can we physically remove the hazard? If not, substitution. Can we replace it with something safer? Third, engineering controls. Can we isolate people from the hazard with physical barriers or ventilation? Fourth, administrative controls, changing the way people work through standard procedures. And finally, personal protective equipment, or PPE. Let me point out an incredibly dangerous mistake amateur safety programs make all the time: relying on PPE as a primary defense. No, PPE is your absolute last line of defense when every other systemic control has failed. Take high-risk laboratory environments, for example. These places demand rigorous operational discipline because they concentrate multiple hazard types simultaneously. You can't just store chemicals alphabetically. Flammables absolutely mandate fire-resistant cabinets. Acids need acid-resistant segregated storage. Toxins demand locked, controlled access units. Mixing incompatible substances in storage is actually a primary driver of campus fires and explosions. Your operational controls have to strictly govern the physical reality of the materials you hold. We also have to address the biggest human variable on any campus: third-party contractors. Under protocols like those at the University of Sydney, while contractors are operating on your campus, the institution still retains a strict duty of care. These contractors must be legally bound to comply with your safety instructions, and critically, they've got to be continuously mindful of the student population. Think about it. A contractor operating heavy machinery near a busy student thoroughfare introduces massive operational risk. Your safety ecosystem must command contractor behavior just as fiercely as it does your own staff. Part 4. Emergency preparedness and response. Now, what happens when an incident actually bypasses your controls? At that point, your institution's survival depends entirely on its response architecture. Elite institutions, like the University of Notre Dame, use what's called an all-hazards approach. This means the underlying response structure is robust enough to handle literally anything. It prepares leadership for a massive spectrum of crises: fires, active shooters, hazardous chemical releases, extreme weather, and even financial malfeasance. You don't build a new response team for every different crisis. You build one elite command structure that adapts to any hazard. Once a crisis triggers, your tactical response operations have to be executed flawlessly. Drawing from the University of Houston's emergency management plan, your immediate goals are singular: minimize casualties and minimize property damage. This means rapid deployment of warning notifications across the campus, executing coordinated evacuations or shelter-in-place orders, and seamlessly integrating with external first responders. Listen, there is zero time for committee debates during a response. These operations must be scripted, drilled, and executed with absolute military precision.
Part 5. Compliance and continuous improvement.
To make sure these systems don't just degrade over time, you need standardization and data-driven improvement. This is where international ISO certifications come into play. ISO 9001 ensures quality management across your services. ISO 45001 is absolutely critical for health and safety, specifically for managing those high-risk labs and workshops. And ISO 2101 focuses on educational organization management. Adopting these frameworks proves your competence to regulators, sure, but more importantly, it mandates continuous auditing. It forces your institution to measure performance, identify the gaps, and implement corrective action on a continuous loop. But to really anchor all that high-level ISO theory into ground-level reality, you need data. Look at the St. Clair College reporting protocols. Documentation must be completed within 24 hours of an event. And this isn't just about filing paperwork to keep HR happy, it is about harvesting intelligence. Every near miss, every minor chemical spill, every single contractor violation is a vital data point. It tells your governance committees exactly where the system is failing before a major catastrophe actually hits. Which brings us to our final provocative challenge for you today. Is the safety of your institution predictable by design, or is it just dependent on luck? Because a mature environmental health and safety system is defined by the predictability of its outcomes. If your campus goes a whole year without a major incident, but you can't structurally explain why, you're just relying on luck. And trust me, luck always runs out. I strongly urge you to take the professional frameworks we've covered in this masterclass, immediately audit your governance, map your risk ecosystem, and engineer a culture where safety is a guaranteed operational standard. Thank you for joining this premium training session.